Exercises for if, else. The first problem I gave you is a game of randomness in which we have two dice. One is for the player and one is for the computer. Whoever gets the higher score wins, and if both of them roll the same value, they tie. So we need to import the random library, set up a random object for the roll of the dice, and two integer variables initialize to a value that is impossible for the game, one for the computer that represents the die for the computer, and one for the player. That one represents the die for the player. With these longer exercises, I highly recommend that you write the comments for all the different sections of the algorithm. And perhaps also you would like to outline a little bit what the program needs to do on paper. So that way you know in which order you need to do the instructions. So remember that we declare and we initialize variables, then we get the values, then we can process something, we can get something done with those values that we have gotten, and finally we display output to the screen. As we're working on this exercise, we're going to see that we don't truly have a process, so we're going to eliminate that extra step. But as you remember, we always need to consider all the different possible steps of the basic algorithm that a program may run through. So to get the value of the roll of the die for the computer, I would write the statement that generates a random integer using the die roll object that I created and storing the value in the variable for the computer. I put a 6 in parentheses because the die has 6 faces, so 6 different numbers, 1 through 6, and the values of the faces of a die starts at 1, so I need to add 1 to the random value that it generates. We're going to do the same for the computer, for the player. So I copy the line of code and I simply change the variable where the value is going to be stored. So we don't have a process, so I eliminate that step because once that we have the value, let's say 3 for the computer, 6 for the player, I can use an if statement that simply displays to the screen that the winner is the one with a higher value. So we need an if, else statement that checks for the winner. And remember, when you write the conditions, you should write them always in the same direction. So if you start with the player, here I changed the direction of the condition because I read the problem and I was focusing on the player's perspective. So if you're focusing on the player's perspective, you should always start the condition with player. So if player is greater than computer, then it means that the player has won. So we will display the corresponding message to the screen. Since these are alternative outcomes, meaning that we cannot have the player win, tie, and computer win, then these are alternative outcomes. They're mutually exclusive. Sorry about that. Mutually exclusive. So what that means is that when one condition is true, the other ones will not execute. And that is what we achieve by using this control structure if, else. So else if the player's value for the die equals the one for the computer, it means that there is a tie. Otherwise, it means that the computer wins because there's no other option. So when we build it and we run it, we need to run it as many times as necessary so we can see all the possible outcomes. Now, in this program, the way I have set it up, you're going to see that I do not have the value of the die. So I don't really know if this is working correctly. We tie, I win, you win, but it doesn't say who got what number. So we need to edit this program so it shows the value of the roll of the dice, so we know who got which value, and we make sure that the if statement is executing correctly. Also, the player wants to see what value each one uh, has gotten. Otherwise, it's no fun. So here we have the output statement that displays what each one has gotten for the role. And after we edit this program with this additional output statements, and notice that I put them in the output section right after the values have been generated, and then I evaluate them. Um, could this be done in the opposite? Display the value after I say who wins? Yeah, but normally we roll the die, we see them, and we determine who the winner is. So now you get a 2 and a 1, and it says the player wins, etc. And I think I had to roll it a lot of times until I got a tie, and there you have it. So then we're going to edit this uh, to make it a little bit more sophisticated. And we're going to add more rules to the game, right? So this is the basic game. We see that this works, and now we're going to edit it. In example number 2 or exercise number 2. So we want to have a bank, and we want to have a bet. So if we are going to ask the user how much they want to bet, then we need to accept that from the keyboard. So it means that we need to add an additional import statement for the keyboard to be understood by the program. So we can have multiple um, libraries in a program. And please remember that I mentioned do not use the asterisk to signify import all the libraries, because it defeats the purpose of why the creators of Java have the libraries. The libraries use memory, the program will be sluggish. If you import all the libraries, it is true you can do anything you want, but that's not the way the language was created. It was created so we import the libraries that we need. So we need to add an object for the keyboard, and now we're going to be able to prompt the user. Where do we prompt the user? Well, we want to prompt the user before we roll the dice. And when we prompt a user, we're getting a value from the user. So we write the two statements, the prompt and the assignment statements, in the get value section of the code. So prompt the user, how much would you like to gamble, or how much would you like to bet, or anything like that. And then the next line needs to be the assignment statement that says that the bet equals the input from the user. So bet equals keyboard dot next, and whatever the data type is, and we made it an integer because we normally gamble a whole number because it's a chip. Um, this program could be uh, improved by making sure that the input is correct. Because what if the user enters a value that is higher than what the user has in the bank? That wouldn't be possible, right? It shouldn't be possible. So we could have more if statements that check for the input, but we kept it simple because this is complex enough for us right now, and this was just a quick lab. So um, I thought this was complex enough. Notice that now when the player wins, also the bank gets increased by the amount of the bet. So bank equals what I had in the bank so far plus the bet. Unfortunately, this program um, starts always with the bank at 50. So every time you run it, you're going to go back to 50. It's not going to remember the new value that you have for your bank. Notice that I needed to put curly braces for the first condition because there are two lines of code. The else if only requires one line of code because the second condition is for the tie and the bank doesn't get modified, so we don't do anything. And the else is the case for the player losing, so we need to decrease the bank by the amount of the bet. So bank equals what I had on the bank right now minus the bet. And then in the output, beyond the if statement, we need to display the new value of the bank. Otherwise, the user doesn't know whether they have more money or they have less money. So it will be equivalent to the dealer giving the chips to the player, right? So we need to add that line of code, and that would go outside of the structure of the if else. So after the last curly bracket for the else, that's where I'm going to have the output statement that displays the new value of the bank. And then when I build it and I run it, so there is the output statement that is outside the else. And now when I build it and I run it, I'm going to see the value of the bank updated by the amount of the bet, adding the bet or subtracting the bet depending on the situation. So building it, I found an error. I tend to forget semicolons. Uh, it's very common to have that accident because we're thinking about the logic, so we forget a little bit about the syntax. So don't feel bad when you make this kind of mistakes. That's the reason why I want to show you what happens to me when I code it. Even though I know what I need to do, I can make mistakes because our attention is focused on something else. So now the program prompts us for the amount of the bet. And notice that the computer won, and now my bank is $48. And now I'm going to start again with 50. I gamble 10, and I win, so now I have $60, and so on. The issue when you're making a program interactive is that it kind of slows it down when you want to check if the program works. So something that we do is we comment out that section and add in, the forward slash with the asterisk in, and closing that with the opposite. So that way we can, what was I going to say? So, and we can hard code the values, so then we run it with different values. So here's the one that we want to see those faces of um, the die. So it means that we want to generate the Unicode of the die. So instead of adding one, we add the starting code because all those characters are in a sequence, one after the other. We can simply add that value. And what it means is that we want to convert the Unicode to a character to see um, the face of the die when we execute the program. Now we get all those squiggly lines because the line char, the declaration is not finished. So don't freak out when you're editing a program and you start seeing squiggly lines. It's because if a statement is not finished, then the program doesn't understand the code afterwards. So once that I put the semicolon at the end, as long as the syntax is correct for that line, then all the errors are going to disappear. So here I'm declaring the character variable for the face of the die for the player and for the computer. And I initialize them to any character that is not one of the dies. So what happens is very simple. We generate the Unicode, and right after the Unicode for the computer die is generated, I want to convert that to a character. Now notice that I made a mistake here. I set up the line of code for the player die. I cannot do that before the player Unicode is generated. So I moved it below the player and I rewrite that line of code for the computer die. So computer die equals the char of the Unicode that I have generated in the previous line. So now there's one more change that we're going to have to make, is that now what we want to display is not the Unicode, but we want to display the face of the die. So we're going to change which variable is displayed on the screen to show the roll of the dice. However, we do not change anything on the conditions. We can still use the Unicodes to compare, because in reality the Unicode and the character are the same value. So we do not need to change the conditions. Perhaps that's something that some of you try to do, change the conditions so it compares the die. And you can do that. You can say if um, player die is greater than comp die, it's still going to work because we can compare two characters and we don't need to do anything to the characters. But because we are writing this code and we know that we're dealing with the Unicodes in these variables and the equivalent characters in the others, we do not need to change anything else except for the output to the screen. So that will remain intact, and what we're going to change is which variable is displayed to show what each person has rolled. So I'll display the faces of the die, but the condition continues to be the same and the bank continues to be the same. So now just build it and run it, and we see that after I set up my bet, it's going to run and show me the characters for the die instead of the numbers. So by using Unicodes, you can make the output a little bit more graphical. It's a little bit more appealing to the eye if you can see it. It's a little more appealing to the eye than displaying the number, because it's nice to see what we would see when we actually roll a die. And finally, the last exercise was totally different. It was about drawing cards, and you do not need to use the Unicodes for the cards But what we're doing is um, we are displaying, we are drawing cards, so the numeric random value will be 1 to 13 because there are 13 cards per suit. And what we're going to do is that we're going to use an if statement to display an A when the value is 1, to display a J for the jack when the value is 11, to display a queen when the value is 12, to display a K when the value is 13. Anything else is the numeric value of the face, so I don't need to write the condition. So this is a way to avoid using the and condition. Now that you know the and, you could spell this out in order, which is technically a little bit better. But at the time of this exercise, we didn't know the use of and or. So this is the way around it. You do all the equalities and everything else will be the default. It displays the value. So I set up a condition for the winner and making a variable that is string data type that is going to hold the game's outcome. So that game outcome variable that I'm displaying in the second to the last line of code is going to read whether there is a winner or if it's a tie. So now when I build it and run it, we need to make sure that we display an ace, a jack, a queen, a king, at least for one of them. So here's a queen and a 10, and the person lost. Now there's a 2 and a king, and the person loses. So we need to make sure that it runs correctly for any circumstance. We have an 8 and a 2, the person wins. So two numbers, and they're displayed correctly and evaluated correctly, and so on. You need to run it until you see that the program executes correctly with all the different conditions. And that's it.